Hello, and welcome to Lecture 10 in our 4 weeks on water curriculum. Today, we are going to be doing a little bit of review on the Lovotex network by doing a case study. Remember that the Lovotex network stands for LOTIC Volunteer Network for collecting data on temperature, electrical conductivity, and stage. Cindy Carlson from New England College explained what these terms mean to you in video lecture 6A. If you need a reminder, refer back to that video lecture. Let's take a look at two different sites being monitored as part of the Lovotex network. The two sites we are going to look at are the Dead Diamond River in northern New Hampshire and Salmon Falls Brook in Nashua, New Hampshire. Let's start with familiarizing you with these two locations. Here I have a map of New Hampshire on Google Maps, and I'm going to zoom in to this northern site. And there's a township up in northern New Hampshire called the Second College Grant. Most of this township is actually owned by Dartmouth College and managed as their outdoor recreation area. If I continue to zoom in here, you can see there are two rivers forming a kind of a Y. This river here is the Dead Diamond River, and the Lovotex sensor is actually located right about here, and I'll show you that on the Google map. Now let's look at where the Salmon Falls Brook location is. Again, I've got New Hampshire here on Google Maps, and I'm going to zoom into Nashua. And this is Salmon Falls Brook here. Even though it says it's Hassel's Brook, it's not quite labeled correctly. And the Lovotex sensor is located right about here. And again, I'll show you that on the Google map. And here we are in Google Map, just to give us a little bit of a different perspective. You can see the Second College Grant up here in the Dead Diamond location, and Nashua is down here with the Salmon Brook Falls location. I'm going to start with the Dead Diamond River. As I zoom in here, and Google Maps takes a second to clarify and sharpen up, you can see that there's a lot of green in this area. It's pretty much all green. We have some other water bodies in this area as well. But you can see the Dead Diamond River as it snakes its way down through the woods. You can see a road system here following another river system. And you can see some open fields and some places where houses are located. But very little road structure. There's some dirt roads back here, some old cuttings. But again, it's largely unimpacted by road systems and urbanization. Okay, it's all trees. And one thing that I want to point out in terms of the lack of road systems is that this is actually a gated piece of property. As I mentioned, it's owned by Dartmouth College, and it's an area that Dartmouth alumni can go into and recreate, but there's not a winter maintained road system here. So even though you might see this road here that sort of parallels the Dead Diamond River up through this area, that road is not maintained for winter travel, and so it's not salted at all. Now let's look at this Nashua location. So if I zoom in, already as I start to zoom in, you can see there's some green over here and down below. But look at the lack of green in this Nashua area. Okay, I'm going to continue to zoom in here. Salmon Falls Brook is right in the heart of Nashua, and so here's the Lovotex location here, and you can see that the Salmon Falls Brook comes through this marshy area, just upstream of where the Lovotex sensor is. But you can see all upstream and all around there's a high density of roads and parking lots in this area. And this means that there's increased salt usage in this area for road safety. Zoom in here. We actually have a couple of schools right in that general area as well. One thing I want you to think about is after all the salt is spread all winter long, where does that salt go? Where does it end up? If you think about it, during the times of melt in winter and in the spring when there is major snow melt and lots of rain, all that salt gets washed down into the local water body. And so in the case of Salmon Falls Brook, all of these roads and parking lot areas that get salted in the winter, that salt, that rock salt, is going to get dissolved and flow down into this local water body. In this case, Salmon Falls Brook. Now let's take a look at the graphs of these two Lovotech sites that I created using the pre-written code for R that I've showed you in a previous video. I had some struggles when processing these two data sets using R in that some of the time frames that I wanted data for, it just didn't exist. Let's start with talking about temperature. I want to remind you of something that Cindy Carlson pointed out to you in video lecture 6A, and that is that when we have an increase in pavement in an area, we often see an increase in temperature in the local water bodies. And actually, if you look here, I'll point out to you that the Dead Diamond River is represented by the black, and the Salmon Falls Brook is represented by the red. You can see that I have an just automatic higher temperature in Salmon Falls Brook than I do in the Dead Diamond. And I'll point out to you that the data for 2013, I believe. The data for 2013 for the Dead Diamond starts at the beginning of May, and that's because there's so much ice buildup in the Dead Diamond River in the winter that we actually pull the Lovotech sensors so that they don't get washed downstream with that ice during the winter. So we do not collect data in the winter for the second college grant. But you can see as we move our way through May, June, and July, the two lines are very similar in the pattern that they form, but the Salmon Falls Brook one is several degrees higher than the Dead Diamond one. And that trend continues through the rest of the year that this data was collected. So in August, you see that same pattern, September, and then in October, there was a weird glitch. There's something going on here where the temperatures are very similar, and then you can see that the Salmon Falls Brook data actually falls off there in the middle of October. Now let's take a look at specific conductance. And I only have two different months represented here, and that's because this is one of the types of data collected that I couldn't get represented using that pre-written R code throughout the same months that I just showed you for temperature. But this is still valuable to look at. We can see a striking pattern, first of all, in August, in that the Dead Diamond River is very stable in terms of electrical conductivity. Remember, specific conductance is a proxy for electrical conductivity. You can think of them as the same thing for this project. So we see that there's a really stable holding pattern in the Dead Diamond River in both August and throughout October and into November. However, the Salmon Falls Brook site, you can see some pretty wild patterns going on here, really changing numbers for that specific conductance. It's a lot more erratic. So what are the factors influencing the difference in patterns that we see in these two locations? Well, first of all, we're going to go back to pavement. And if you recall from video 6A, pavement can have a big impact on the overall temperature of a moving water body. If we look back to those Google Earth pictures, here's our Salmon Brook site, and you can see the presence of all of the paved roads and the paved parking lots here, as opposed to the Dead Diamond site where you have some dirt roads present a little bit, but it's all wooded. Also, groundwater influence. I can tell you, since I've spent time up in the second college grant, that the Dead Diamond has a big groundwater influence. And New Hampshire Fish and Game has actually documented that over the years by placing temperature data loggers throughout that water body. That's going to help the Dead Diamond stay more consistent with its temperature, and in tandem with the lack of pavement will keep that temperature low. And also higher human population. We'll go back to those Google Earth pictures one more time. Obviously, we have a higher density of roads and parking lots in this area because there are more people living in this area, which means that it's not just road salt that's running off into this local water body. There's going to be a lot of other types of runoff, including fertilizer, including other dissolved solids, human waste, animal waste, and those things all contribute to specific conductance. This concludes this video lecture. Please remember to log on to the 4 Weeks on Water curriculum website and take the quiz associated with this lecture.